Let's keep the momentum going, shall we? With our next session on peering and operations. To share with us here on the technical updates of the RouteViews project is someone whom I'm sure needs no introduction. Representing the NSRC, please help me. Welcome to the stage, Philip Smith.
No, this is not going to work. Okay if because otherwise I'll be... all right, me again. What was it you're saying, what I've got to wear for the second time on the stage? No need to introduce me, okay. Was it mustache or, no. Anyway, so I don't really have very much time. What I've done with this presentation, as I was telling the program committee, I just want to give the technical update about RouteViews. What I've actually done is I've left all the slides here, the general slides that we use, because some of you don't know the project. And we did talk about it in the BGP workshop we were doing the last 4 days. So some of you are not aware of the project. There's a lot more background information, but for those of you who do, I just want to give a technical update so that we don't take up all the afternoon. So where's the clicker? There we go. Right, so without going into huge detail, RouteViews was started in around about 1995. I mean, the motivation was really, I was working for an ISP in the UK at the time. The motivation was, what do our routes look like somewhere else on the planet? I mean, we knew what we were announcing, but what did it look like somewhere else around the globe? This was in the early internet. And you could hardly say, hey, UUNet, can I log into your router so I can look at my BGP table? Or, hey, Sprint, can I log into the router to see the BGP table? We couldn't do that. So this project was started at the University of Oregon, 1995. A router was set up, it got BGP feeds into it, and anybody could log into that router and look at the BGP table. So when your customer was complaining about internet not working, you could actually see what you looked like. So there's all the background about the project and the funding. It's a community-driven project, has been ever since, running this is the 28th year. The data has been recorded since 1997, so we don't have anything older than that. So if you have BGP tables that are older than 1997, we would love to see them. So they must be lurking on a tape somewhere in your archives or a safe or wherever. I mean, we've been looking exhaustively, but nobody seemed to have recorded it. And I regret all my years working at ISP, all the show IP BGPs I saved, I don't have them anymore. So the team, Owen is here with me. Owen is sitting at the back there, or in the middle. Owen is really the main network engineer now for the RouteViews project, because up to now it's all been a volunteer effort. Nina is the other team member. She has joined recently. She's been well known in the past as peering coordinator for various organizations, so she is now the RouteViews peering coordinator, and the various other folks that some of you have probably seen who have been helping out for quite some time. What it is, it's basically a looking glass. If you know what the looking glass is, somewhere you can log in, have a look, see what your BGP table looks like, and from a particular point in the world. So there are about 50 locations. The uses are many. Reachability, hijacks, bugs, peer visibility, withdrawals, RPKI. We added RPKI visibility about 2 years ago, so you can actually check your validation state of your prefixes. They're located, so the collectors are located at strategic exchange points around the world. We are looking for more locations. We're here in Bangkok, BeaconX facility down at the end of Sukhumvit Road, actually down near Bang Nahat, the facility there. So we have a few peers. We peer the route server at BeaconX, but we want more Thai providers at BeaconX to send us the full BGP table, because that's the most useful data for us. Lots of people use it. Way more than this, but these are the ones we know. This is the current map of where the RouteViews sites are. A lot of them are in North America, because it's kind of based here at the University of Oregon. I live in Australia. I'm kind of keen to see a lot more collectors in this part of the world. And we've got over 2.5 billion of the population living in this area, so we need a few more collectors in this part of the world, in my humble opinion. We're working on it. You can't just spin them up and make them appear like that. So we're working on expanding. There are about 50 collectors at the moment. Probably, we'll be adding a few more this year. What's been happening? We use FRR. There's no secret about that. Free-range routing. Martin Winter's been here a few times talking about it, some of the early BeaconX and TiNogs. And we still have one Cisco router. It started off as a Cisco router way back early on. So we still have one that you can log into and have a look. Moving a lot of the collectors from servers, so physical hardware, onto virtual machines, because that's a lot easier to deploy and manage. Most recent additions, Kicks in Atlanta, DR Fortress in Hawaii, and Interland in Romania. Get lots of offers, which is very kind of you, but we need resources to be able to fulfill those. It's not just a case of, we'll set another one up. It's where we store the data, staff time, and so forth. But this is the main thing I wanted to share with you. So the API is there. We are working on it, like early testing. So rather than you having to telnet into things to have a look-see, you can query the API to find out what's going on. The API, just as a sample of collectors, it's using 10 of the 50 collectors we have at the moment. That's going to be expanded again as resources become available. You can read all about it in the docs there. This one is, Nina only announced this yesterday to the Nanog mailing list. So it's been a long-term project to replace the telnet access by a looking glass. This is a much simpler, more modern way of accessing rather than just giving you telnet access to the collector. The problem with the telnet access is there's every single bot on the planet seems to want to log in and do show BGP, which is just doesn't scale. It's unsustainable. So telnet is going away. Probably in the next few months, we will completely remove telnet. Probably leave it on the Cisco router, and the looking glass access will become the default. So this is just really early warning. If you've got scripts that are telnetting to our collectors, please don't. There's an API for that. And if you want a nice point and click interface, the looking glass is now live. So you can use that. Feedback about the looking glass, please let us know. I'm sure a lot of you use looking glasses all over the world, so we now have a proper looking glass interface for RouteViews collectors as well. So, just some pretty pictures of what it looks like. I think this type of looking glass, the back end you probably recognize, used in quite a few places. So, things you can do. Screen you can't read, but you can see the slides afterwards. Insufficient data for an image. Okay, that's exciting. Right, next project, the BGP monitoring protocol. So this has been a long term in development, causing Owen a lot of headaches, a lot of the team a lot of headaches, just to try and make all this work. So the current flow is something like this. We don't want to give folks direct access to the collectors for BMP, so we're trying to run it all through an infrastructure to make this scale. So the public view is really the stream.routeviews.org. So we're really just trying to replace major components to actually make it reliable, because it's been, unfortunately, rather unreliable, the components we have, just with, memory issues, infrastructure issues, crashing issues, and so forth. So it's a bit, this is a service that some people are using in early testing, but we're trying to replace it while keeping everything going. So it's a bit of a major effort involved at the moment to make all this stuff happen. So once we get this working reliably and we don't have to spend hours each day looking after it, more of you will be able to get access to this as well. So this is a live feed from the collectors, but via this intermediate infrastructure. Behind the scenes projects. So yes, as I was saying, data from 1997, so that all has to be upgraded because the hardware behind here is really old. Computers don't last forever, disk drives don't either, so that all needs to be modernized. Tooling is modernized. The operating system, we still have CentOS out there, and as you know, CentOS is obsolete, so we're moving everything over to Ubuntu, which is our standard. FRR, a lot of tuning work we had to do. So, you know, this nice guide by ESNet, Energy Sciences Network, has been really helpful in speeding up the behavior of FRR. And we have a big issue with badly behaving peers. They're slow or they're noisy. And by noisy, I mean thousands and thousands and thousands of updates per minute, which is not happening on the internet, but these peers are trying to tell us that this is normal behavior. So it causes a big issue for us because we capture not only the routing table, but also BGP updates. And you know, consuming gigs of disk space every few minutes just on noisy updates is not good for our infrastructure. Future planning, more collectors. Yeah, what else? Using it, what have I got, 10 minutes? So, you know, use it. I've got a lot of examples of looking glass uses here, so you can pick the looking glass or the collector you want to go and have a look at, and do the normal things you would logging into something that's got a big BGP table. This is the one at Links in London. So you see, well, you can't see, but you'll see in the slides, lots of full BGP tables. We've just hit, so Micron 21 there has given us over 1 million prefixes in BGP. So that's really where the V4 table is looking at. A typical use case that Nina was talking about the other week was peering negotiation, maybe. You know, who are the upstreams, who are your peers, who are your customers? So I've picked a Thai provider at random. Sorry, Symphony. Picked one at random. I've had a look at a multi-hop collector, AS132280. Let me guess, not enough resource for my image. Okay, yep, no resource. That's a shame because it shows you the BGP table as we see it. You'll have to look on the slide when it's published. It shows the BGP table as it's seen at the University of Oregon. So you can see who the transit providers are. And then the next one, I'm now going to BeaconX because Symphony peers with us. They give us the full table at BeaconX. And so we can have a look at that, and let me guess, blank. Oh no, it works. Right, so again, we look at 132.280, and we see who the downstream ASs are for them. So you could look at them and see how good the peerability and how useful it would be for that. Right, so that's one type of example. Barrett Lyon, this is last year, put together this amazing YouTube video taking all the RouteViews data since 1997 and made a movie out of it. So it shows the growth of the internet really since the start of the data here. So both the V4 and the V6. So if you like visualization, please don't play it on the hotel network because the hotel network is not very fast. But have a look this evening when you go back home. If you use our data, please say thank you publicly. This is a community effort, it's not a commercial product. There are lots of commercial services that do similar things. This has been a community effort ever since. We have to go looking for money, begging for money to keep paying Owen. So, and we want to keep Owen. So we really do appreciate any and all the support that we get from the community. Another thing that really, well, it doesn't annoy, but it does annoy me, is people who use RouteViews data and, you know, selling services or providing services, if they don't understand what's going on, they send their customers to talk to us, right? We can't do anything, right? We just collect what's on the global table. We can't fix mistakes made by network operators. We are not going to write to a big ISP on your customer's behalf to fix something they're doing. We just collect. We can't fix bugs in BGP implementations. We get those requests all the time. We can't remove BGP announcements. If it's in the BGP table, it happened. We are not in the business of rewriting history. Please don't ask us to do that. And lots of people do. Oh, if my ministry sees this in the table, they will shut me down. That's your problem, not my problem or our problem, right? So we can't do things. We simply collect what we see in the global table. So please don't send your customers to us for support. We cannot help. And I will be very polite in replying along those lines. Peering with us, as I said in the peering personal, we have a selective peering policy now. I mean, we need to have the ability to be able to say no. Some of our peers are hugely problematic for us. The noisy peers that I was talking about, giving us vast amounts of updates per minute. I mean, we have to have an ability to say, look, you need to fix this, or tell us what you're doing. We were happy to work with you, but we need to fix. We cannot have you destroying our collecting infrastructure because your BGP implementation is broken. So we have a selective peering policy now, really to try and give us support to be able to be clear about who we can actually peer with. And also we get quite a lot of requests from somebody who's bought a little hobby router, has collected a few BGP feeds from random places, and then wants to see them appear on RouteViews. That's not what we're there for. We're trying to help researchers see and understand the global internet, not support the hobby BGP learning folks. Everybody needs to learn, but this is not what RouteViews is for. Right, so at any exchange point, we peer with the route server. So we don't want to peer with you bilaterally at an exchange unless you're going to give us the full table. If it just replicates what's in the route server, not interested. Right? So we do want to receive these full tables. And it amazes me, we still get people who say, the BGP is up, you're not sending us anything. We don't have anything to send. Maybe we should just get a beacon address or something like that we can just send to people so they tell us, or don't keep asking us to send something, right? We're just a collector. We don't send routing information. What else? General requirements is what Nina has put together. So these are generally what we expect folks who peer with RouteViews. So we're a little bit selective now. What else? So exchange point, as I mentioned, we'll only do multi-hop peers with folks who are not at exchange points. So some countries we don't have collectors at. We're working on that, and hopefully we can come there soon. And some network operators simply are not at any exchange points at all. So we'll have multi-hops there. We're not going to peer with you at an IX and then have a multi-hop also, unless your multi-hop is extremely different from what we see at the IX. What else? Anyway, so this is really the explanation of the selective peering policy. What else? Hosting, I'll skip over this. I mean, we have one here in Thailand at BeaconX. Other parts of Southeast Asia, I mean, it really depends. We have some key areas we want to get to, hopefully later this year as resources become available. What else? The software I mentioned, and the host and so forth. So really for supporting RouteViews, as I say, it's a community project. We're not trying to sell anything with nothing to sell. Everybody can access the data. It's all archived. So please use it. Please tell people about it. A lot of researchers use the data. You know, not only researchers, commercial products and so forth. So any support that we can get, we really appreciate. If you want to peer with us, please do. If you write research papers, please do. Our DOI is this. We finally got one. So that means you can find any research paper that references RouteViews if that is actually noted. If your product or service is commercially successful, we would love to hear about it. Please send checks to Owen. No, seriously, but no, if you would like to support the project, we would happily receive sponsorship. We'll recognize all sponsors, but to keep this useful service for the whole internet community going, it does cost money. And as you know, things aren't getting any cheaper these days. That's pretty much it. Hope it's a useful update. Any questions? Probably better we have them during the break. I'm here tomorrow as well, or can talk to you in the social event this evening. If you don't want to talk to me, please talk to Owen, and he'll be happy to update you as well. Thank you very much.
Thank you very much, Philip, for these technical updates on the RouteViews project. Speaking about routes, we have to therefore talk about traffic. Moving on in the flow of our conversations is a presentation on optimizing traffic flow. To deliver this presentation, I'm pleased to introduce Kams Yeung, who is a senior network architect at Akamai Technologies, which is the world's largest CDN, by the way. Kams' area of expertise covers peering, routed interconnections, and capacity planning, and much more. So please help me welcome to the stage Kams Yeung.
Hello. Yes. So, hello everyone. My name is Kams Yeung. So I'm one of the network architect from Akamai. So today I'm going to talk about Akamai, a very brief introduction of Akamai, and also how do we map traffic. I think there's a lot of ISP are asking me the same question all the times, but I will also talk about like some best practice and recommendation for to optimize the Akamai traffic. So let's start with the introduction. So I think a lot of people know that Akamai is a CDN. That's true, but this is where we found our company like 26 years ago. But now we also expand into security and also cloud computing. So we just acquired Linux like 3 years ago, and this is our latest global cloud infrastructure. So this map actually includes our edge pop, our CDN cache server, our network infrastructure, and also our computing. So we have core computing side and also distributed side. So altogether we have more than 4,000 edge pop in 1,200 networks. Of course, in Thailand, we also have a lot of pops here. So next slide, I'm going to talk about our deployment more specific in Thailand. So in Thailand, our cache server are mostly inside the ISP because this is the way that we have the most optimal performance. So within the ISP, it's closer to the end user. So we are deployed in all the major ISP, and not only in Bangkok here, but we also deploy in different province, different city, so that we can optimize the traffic locally for that local city. So we have Chiang Mai, Koh Kam, Nakhon Ratchasima, Pattaya, Suratani, and Hat. So we have multiple cities. But for our infrastructure, this is where we do peering or PNI. That will be in Bangkok. I think that is still where most of the internet gateway is. So we are in True IDC and in Gestel data center. Those information that you can also find on our PingDB. And on a day-to-day basis, we are having more than 90% of the traffic to a Thailand user within Thailand. So this is the peering forum, right? So we are talking about the Akamai peering in Bangkok or in Thailand. So we partner with BKNIX since 2016. So we are connected to them like 9 years ago, almost 10. And then we have subsequently, I think there's also a lot of more new emerging IX coming into Thailand. So we have also connected to BBX Thailand from 220, and then THIX from National Telecom, and also M6. So we are connected to most of the local IX here, so that we have multiple ways to send traffic. So if you are, sorry, I missed the ping personal, but if you are connected to any of those IX here in Thailand, we have an open ping policy, so you can also drop me an email or contact our ping team, and then we can set up the peering section there. So now we talk about the Akamai infrastructure and also our peering connections in Thailand. I'm going to talk about the traffic, because this is a lot of questions that a lot of people keep asking me. And our traffic is a bit different, I think, or actually all CDN are different. So before I go into how we map traffic, I think it's good that I clarify some basic information about Akamai. So most of the Akamai clusters that we have are all independent. What that means is they are like islands. So they are not interconnected with each other. So what that means is if you only connect to one of our cluster, then you probably only get the content on that cluster. And we have, how do we serve the content? So you probably see on your traffic flow that you day-to-day, you see a lot of traffic from our AS. So we do carry a lot of traffic for our content customer. And so the content that is not belongs to us, but it belongs to our content customer. So we do have, the way that we serve is more like a caching platform. So we do cache the content in the cache server so that the content will be stored there, and then we serve the end user. So we operate, so most of our edge pop is actually essentially a cache server, or we call reverse proxy. And we operate as a multi-tier. So traffic would, the end user will go to our edge pop, and edge pop will go to a mid-tier before it go to our customer origin. And each of these clusters, they have all independent different connectivity. So let's say if we deploy inside an ISP, the connection will be like single home to the ISP. But if we connect to our public infrastructure, then we have our own transit link, we have our own IX link, our PNI link. So all cluster will have different connectivity. And how do we map traffic? I think this is something that a lot of user, a lot of ISP are asking. We map traffic based on DNS, and also not the user prefix, and also a lot of other criteria like content availability and also the performance. So you understand that this basic, then we go into how Akamai map traffic. So basically we have two types of cluster. So one that cluster mean our edge pop. So we have one that called private, because actually I think most of them, like 90% of our cluster is is the edge pop. So what that means is serve specific to an ISP because it sits within an ISP. So in Thailand, let's say if we are in AIS or in True or in TOT or in wherever ISP, then the traffic that we have is we call AMP. So we have the partnership with them. So the traffic is only served there. The other thing, the other cluster that we have is called public cluster. So a public cluster would mean the traffic would be inside a data center. So as I mentioned before, in Bangkok, we are within two major data centers, True IDC and Gestel. So these two are the data centers that we can connect to IX and PNI. And this is a typical diagram that we have. Yeah, if you look at like the end user in the ISP, so chances we have a private cluster with them within the ISP, only serve to the ISP. But we also have a public cluster that connect to the ISP in different form. Could be an IX connection, could be a PNI format, or could be a transit link. So usually what we do is we map the end user to the closest cluster, and the closest cluster could be a private cluster or could be a public cluster. And that cluster will have to fetch the content. So the content origin is hosted by our customer themselves. So sometimes they have their own infrastructure, sometimes they host it in a cloud company. So this is out of our control. But basically, when a user requests a content to the edge server needs to have the content. If it don't have, then they have to, if a cache miss, then we have to fetch it from the origin. So you see that we also have a lot of those green color. Those are the cache field traffic. And then I mentioned that we have, other than the edge, we also have parent, because the edge traffic don't go directly to the origin. It usually go to another cluster. So those cluster request mid-tier. So the edge traffic will usually go to a public cluster, and then a public cluster will go to the origin. So this will enhance the maximize the offload. So it's not all edge traffic will go to the origin. Otherwise, the origin will be overloaded with a lot of origin requests. Now, because a lot of ISP operate in BGP, right? That is the standard. No doubt on that. But because I mentioned that when we Akamai map traffic, on top of BGP, we also based on DNS. So a lot of ISP will do different BGP traffic engineering technique, try to steer the traffic. But you will find that a lot of chance that it actually don't work very well with Akamai. And here's what I'm going to explain. Because in Akamai, we are a performance-based CDN. So what we do is, we also measure the network performance. What that means is we measure the packet loss, the latency, the jitter, the link utilization. And then we also have to depend on the server capacity. So chances if the server capacity is full, then we'll map the end user to other customer. Or the server is having a maintenance, then we have to overflow the traffic to other customers as well. And the cache placement policy means our content customer, they may choose to put this content in a specific country due to their own content policy. And then the third thing is the caching policy is also defined by our customer. So they may have their own what we call the global traffic management to decide how they want the Akamai to send their traffic. So there's a lot of different factors other than BGP that impact how we send traffic. Now, you will find that a lot of people try to do ASPARC PPN. But I mentioned because all our customers are independent. So if you PPN to one specific customer, it don't impact other customers as well because we are not a continuous network. ASPARC PPN, it works if we are a continuous network because otherwise you only PPN to one customer, but the performance is still good, we'll still serve from there. The other thing is same. On BGP, a lot of people use MED matrix because you have multiple links with us, and then you think that your MED could steer traffic. But most of the chance is also not working because chances you have multiple links. The multiple links are connected to different customers, so they are not exchanging BGP information. So we have no way to understand, to compare the MED. So this doesn't work. Also, the other thing is prefix length. A lot of people do specific route to transit A, transit B. I understand that you want to do traffic balancing, but this is not very well with us because as long as you are sending a covering aggregated prefix, then we think that we can send all traffic to that prefix. So all this, So all this doesn't work, unfortunately. But the good news is, you can work with us, and after you understand how our DNS mapping algorithm, and you can also implement some recommendation. So the way that you can still optimize. Just you have to be aware that BGP HGPO is not the only way to steer the Akamai traffic. So what we do is we recommend that you talk to us. So you can email me or contact our peering team. They can able to answer you if you think that the traffic is sending too much or too less. And I'm going to next section. I'm going to talk about the best practice and recommendation when it comes to Akamai. So we are happy to work with each of you. If you don't want traffic on a specific link or you don't want traffic from your upstream, we all understand that because we also want to have the most optimal user performance. And it is you who knows that where is the best way for us to send traffic to you, because we don't want to congest your link as well, because this also impact our content customer. So I'm going to suggest some best practice when it comes to Akamai traffic engineering. So number one is because I mentioned that we are based on DNS. So the best thing is you have your own DNS server. I think a lot of ISP will do that because you need to have DNS because you provide internet service to your end user. So you are not only giving them like an IP address, you also give them a DNS so that chances they get it from the ISP through DHCP, right? So if you have your own DNS IP, then we can check your external DNS IP, and then we can see how we can map traffic. And the external IP chances, we also use that as a monitoring. And the other thing is, if you are a large ISP, you operate in multiple cities or multiple countries, we also suggest that you have Anycast, because then your end user always get the same DNS IP. You don't need to have different configuration, different DNS server. But I also recommend you to localize your DNS server. So what that means is your end user facing IP is always the same, Anycast, but your external IP would different in different cities or different countries. So in this way, then I can, Akamai, we can recognize so different IP, then we know where the end user are actually coming from. The other thing is, if you can, for whatever reason, set up your own DNS server, I would recommend that you use Open Resolver from Google and OpenDNS, because we work with them for the ECS, the End-Client Subnet. So we are able to see the end user IP if you are using Google and OpenDNS, but not other Open Resolvers. Of course, you also maintain a good quality of your DNS, because chances we may use that DNS as a proxy to measure your network performance. The next step I would suggest is to have the most optimal Akamai traffic flow is you announce if you're peering with us, then you announce all your prefixes, including both like DNS and end user, so that when we map your traffic based on DNS to one customer, but if you don't send us a user prefix, your end user traffic may come from your transit link or a third party. So this is very difficult for us to control. And if you can't do that, then chances we may actually blocking your DNS prefix, so we may not send traffic from a particular peering link. So yeah, this is because a lot of people are sending end user on different links, but if you want a optimal Akamai traffic performance, you have to send the both DNS and user prefix to us. And you don't need to worry about congestion, because we are link aware. So if you, as long as you send all your consistent prefix to us, we are able to detect any congestion. So we will also try to avoid congesting any of your links. So you don't need to worry too much about link congestion. And if you are not connected to Akamai directly, you have to buy upstream or transit. Also, I would recommend that you send a complete prefixes to your upstream, so that we have a consistent traffic flow. The other thing that I mentioned is a lot of people are doing specific route, which is fun, but just remember that when you send a specific route to us, you have to remember that the aggregated IP block, that we can also still send traffic to all the specific inside the aggregation block. Because as I mentioned, if customer A that get a /20 from you, I would expect that customer A can send to all IP within that /20, versus like I won't route traffic to another customer for a specific route. So you remember that you don't filter traffic. I mean, you just announce what you promise that you can deliver. So if I can send traffic to that /20, you send a /20. I think this is a very common protocol. Because the other way is because our router don't have full internet route, so I probably can't get a specific route from somewhere else. And I know we are lack of IPv4, so a lot of people are doing carrier grade NAT. But I would still suggest that if try to avoid, if possible. If not, then you can try to put our Akamai server outside of your carrier NAT, so we still see the external public IP address. And of course, I would strongly recommend that you need to implement IPv6, because this is the way to go. Yeah, and if you have a problem with IP address, IPv6 assignment, or you want to understand more about how to implement IPv6, you can approach the APNIC help desk. They have resources to do technical assistance. So I actually look at the IPv6 capability. This is actually APNIC data. Thailand is doing actually a good job. That is actually now over 50% of the Thailand user having an IPv6 capable. So yeah, so if you have a Akamai CAP server, enable v6. If you have a peer with Akamai, enable v6. Because if your end user support v6, we will also prefer to send traffic through v6 as well. But if I don't have v6 connectivity with you, there's no way that I can send v6 to you. So that's all I have. I just want to summarize what I have been talking today. So number one is remember that Akamai, we are not only CDN, we are connected Akamai Connected Cloud. We have a lot of edge server, and I talk about our deployment. We're quite distributed, not only in Bangkok. And for traffic engineering, just remember that we use on top of BGP, we also use DNS. BGP only effective when it is at the same cluster, but chances we have more than 1,000 clusters. So chances you may actually connecting to different clusters. So remember that some of the common BGP technique actually don't work with us. And the last, we'll talk about the best practice. So set up your own DNS server because we map traffic based on DNS. Maintain a consistent route. I think this is quite important. And then do not filter any traffic. That you announce to us. And I try to avoid carrier grade NAT and also enable V6. So that's all I have today. If you want to contact me, this is my email address. And if you want to peer with us, so we have 3 different networks actually. So we have CDN and we have a DDoS mitigation called Prolexic, and then we have a cloud compute that also on another AS. So in Thailand we only have CDN, but if you have network in outside Thailand, let's say Hong Kong or Singapore, we do have the Prolexic and the NOC there. So that's all my presentation. Khop khop. Any questions?
Any questions for Kams? Going once, going twice, sold to the highest bidder. Thank you very much, Kams,
Thank you
for your presentation. Moving on with our schedule, I'm pleased to introduce our next speaker, Wollny, who is the Director of Interconnection Strategy at Hurricane Electric, thus supporting the company's global network reach across 56 countries and in more than 320 internet exchanges. Walt is therefore very experienced in global connectivity and in expanding into new markets. Please, Walt, take it away. Thank you.
So it's been a while since I've been to Bangkok for this event. The last time I was here was in 2017. So I want to go a little bit off script and talk about what's new at Hurricane. So I'm going to share my screen and go through this. So who knows me? Who's met me before? Well, not that many. Wow. So I've been doing this for 28 years. I'm now at 11 years at Hurricane, and we're on 320 internet exchanges. I did 4 years at Amazon, and that was great, and 13 years at Microsoft. My one sales slide. So we are now the best connected network in the world, according to Telegeography, where we have over 10,000 unique peers, and I owe a lot of that thanks to the people in this room. So today, I want to talk about several new things, but before I do that, I want to show you what's new for us at Hurricane. So this is our map of APAC, and as you can see, we're thickly connected in many different other regions. A new website that not many people know about is he.net/layer2. If you put in 2 locations like we'll actually publish our live time layer 2 stats. And the cool part is that if you want to see what we're connected to and how many paths we have at a data center, you just click on the graph part. This takes a minute to render, but you can just hover over a certain data center and you'll see all the different paths in and out. So that's kind of cool. Also, many people don't know that we have 2 very large data centers in the Fremont Bay Area location. So if you guys want a free rack space and power for your first setup, just email me and we'll get you a free rack and power. How many people are peering with Hurricane? Well, if you're not peering with me, please do so, because I'll give you a full free IPv6 transit table. And that's just what we do. So we have another new website called routing.he.net. So we've been fully RPKI compliant for 5+ years now. And so for this, I'm going to take an example of the internet exchange here in Thailand. So boom. So I'm not supposed to show you this, but I think it's helpful. All these green, this is an internal tool that I use. All these green locations or sessions here show who I am not peering with that I can peer with. And why is this interesting? Because that means I can do a lot more traffic and giving more peering here inside of Bangkok. So I picked one example, and this is not picking on anyone, this is just a random network that I saw. So right here we can see that we're actually rejecting routes. So wouldn't it be nice to know why I'm rejecting something? Yes? Great. So if you go to routing.he.net and you put in your ASN, and this is available for anyone that is peering with me, we actually show the policy that's applied. Not only that, but we also show all the different sessions we have globally. So every single session has a different filter applied depending on what you're advertising. So for you, Kams, you'd have a whole bunch of exchanges globally. So you can just take a look at the reasons why we're rejecting. So if we look for, you can actually see valid. And this is invalid. So it does not match. So you would need to take a look and see why it's not matching, and then talk to your local registrar to get that fixed. And for that case, bgp.he.net, which I'll dive into later, it's based on all the routes that are being fed globally. It's not a view from Hurricane Electric's perspective, but a view from all the different collectors around the world. So our data shows about the policies that are there. We show what's being inputted and rejected by both IPv4 and v6. And the router data thing. The most common reason for rejections is RPI invalid, missing RR route object, ASN origin not met, and private ASN in the thing. So you can take a look at the algorithm right here. Open Google Chrome, boom. And this shows the complete algorithm that we're using for our own homegrown RPAI. So now we're going to jump over to bgp.he.net and show you what's new there. I have a full presentation that's uploaded on the peering website, so that's for you to take a look at. So a network is a network where all the networks are ASNs. So to be visible, that's the only way we can have you in the tool. If it's not visible, there'll be no routing data. You need to participate with different route collectors. This shows BGP from a global perspective, so it'll reflect what the actual BGP table shows. And again, this data is independent of our data, so it doesn't reflect our data. And you see something that's kind of messed up, just drop an email to support@he.net and we'll take a look at it. So this is, I've never shown this before. So if you go to bgp.he.net and you look at this graph, this shows the propagation to the networks that we believe are important, which are these guys. Cool? Cool. A new feature is the super looking glass. So this is an example. As you can see, I didn't want to do this via slide. So this we can do it like this. And you can also filter by ASN. So this is pretty new and exciting. This is also our super trace route. This has been developed this year. So this will give you a link to our website, and you can take a look from different locations. And this is real-time data. Another thing is visibility. So this is the prefixes that we're noticing from this provider. And if we can click on this, we can actually take a look at how the rest of the world sees the visibility of that network block. This is all new stuff. And this shows the route propagation. So this is another new tab as well. So we actually need your help. So if you can go to Looking Glass, bgp.he.net/LG, and type in your ASN, we would like you to come and help make the internet better by providing your feed to us. One thing that I get a lot of questions on is how did Hurricane Electric get their name? So this year is our 30th anniversary for Hurricane Electric Internet Services. 30 years ago, before the website and the hosting and the backbone was created, the president, Mike Lieber, and his dad were repairing electric motors. And Mike Lieber, the owner, says, hey, I need a web page, and let me get a fractional T1. So from that one server and a fractional T1, he was able to build the company that we have today. So many of you don't know that my father died about 5 years ago. And so my dad was always working very hard. He was a project manager for the SR-71 Blackbird. So he would always work. And so what I would like to encourage everyone is that when you're home with your parents, take the time to record their life story, because someday you won't have them. And unfortunately for me, the last day I saw him was at his 92nd birthday, and I had a fight with him. And unfortunately, a week later he died, so I wasn't able to heal a relationship. And also my daughter has gone from this high to a grown lady. So take the time to spend the time with your family, because that's all that really matters. And with that, that's all I have for you today. Thanks.
Thank you very much, Walt, and I'm sorry to hear about the loss of your father. And thank you for sharing that wisdom. I think it's an important reminder to spend time with those who are really important for us. You can't take these things back, right? Okay, ladies and gentlemen, it's now time for a short break to recharge and get refreshments. So please join us for the afternoon coffee break just outside the main hall. And it's another opportunity to connect and visit the booths of our sponsors. And let's reconvene here at 4:30 p.m. for our next session on technology and updates, which I'm sure you will not want to miss. Please return on time and see you soon.